We embark on our journey into the future. Let's take a moment to briefly retread the remarkable route of human evolution up until now. From our origins as the first Homo sapiens in Africa to the diverse global population of today, we've undergone countless physical transformations, environmental shifts, enforced relocations, and we've been continually guided and remodeled by our own interventions as well. Our earliest ancestors, equipped with only the most rudimentary tools and an apparently tenacious spirit, managed to triumph over countless everyday challenges. Over millennia, natural selection has then sculpted the human body, favoring traits that over the years have enhanced our chances of survival and reproduction. The size of our brain has changed, the shape of our posture, our average height has fluctuated. Many of our key senses have improved or depreciated over time. Today, we are distinguished by our enhanced cognitive abilities, although we've also lost some elements of physical strength and natural instinct. The modern human can complete countless tasks via a screen in their pocket, but perhaps isn't so adept at surviving in the wilderness. Ancient hominins could run and climb faster on average, but could never move as quickly as someone today in a car, train, plane, or spaceship. Everywhere you look, there's evidence of how we've changed and evolved to get to this point. For some, though, all of what's gone on before could soon be rapidly eclipsed in a big way. It's said that today we find ourselves on the cusp of a new phase in human evolution, what you might call evolution reloaded. And it's one that's shaped not only by natural forces, but also by our own ambitions and technological ability. Close your eyes and envision yourself in the year 2050, or perhaps even further into the future. What do you see? How has the human form evolved? Are we still recognizable? Or have we transcended the boundaries of biology and taken control of our own evolution? When bidding to unveil the future human look, it's a conversation that's inevitably dominated by all of the exciting or daunting possibilities offered by technological upgrades. First, let's consider digital integration, moving beyond the boundaries of flesh. The merging of humans with technology is, of course, a recurring theme in not just science fiction, but also real-world projections. We no longer need to imagine a time where microchips embedded in your body seamlessly connect you to the digital realm. That reality is here and already happening. In late January 2024, the founder of Neuralink, Elon Musk, revealed via X that the first human had received an implant from Neuralink and was recovering well. The long-term plans for such implants aren't entirely clear. On the one hand, it's said that they'll enable those with paralysis to wirelessly control machines. On the other hand, it's speculated that in-brain chips could serve to infinitely expand individual human knowledge, or to one day connect us all to a hive mind. In either case, and along the entire range of possibilities, it's clear that the merge between human and machine will spark massive changes, dramatically enhancing our cognitive abilities and revolutionizing the way we interact with the world around us. However, with such great power comes comparably great responsibility. There are various ethical considerations surrounding privacy, security, and the potential misuse of implant technology. Striking a balance between technological integration and safeguarding individual rights will be paramount in determining whether this kind of technology truly makes our lives better or worse. At the very least, we can easily conjure a bizarre future time when people need to be password protected. Next on the bill, genetic engineering, what some see as crafting our own destiny. Advancements in genetic technology have already opened the door to a future where we can tailor our fundamental makeup. This could mean a world where all hereditary diseases are eradicated, while on the flip side, it may mean a time when all desirable traits are enhanced. Our growing ability to edit genes may give rise in the future to a generation with, again, heightened intelligence, but also increased resistance to illness and perhaps even extended lifespans. The science of aging actually isn't unknown. Researchers can track how, when, and why our cells eventually break down. This means that the humans of the future will almost certainly look younger for longer, due to a predicted explosion of anti-aging treatments. However, this is a field in which the holy grail of biosciences really might be discovered as well: immortality. While this sure sounds like a utopian dream, there are again various concerns about the ethical implications and unintended consequences of our continued pursuit of genetic mastery. Although the history of human evolution is long and pretty spectacular, we've never before had such a direct and immediate say in what happens next. With the looming ability to just scrub out genes we don't want and to proliferate the ones we do, we could well be setting up our species for extinction rather than everlasting life. Think of the human genome as a little like a recipe, and then imagine suddenly veering away from that recipe, adding in new ingredients and taking out long-established ingredients. And it's easy to see how that recipe could quickly turn irredeemably bad. Similarly, there are various campaigns to slow or even halt genetic engineering for fear of our species going the same way. It's another field where a delicate balance is needed, but it's also a near certainty that future humans will be physically changed as a result of the tech and knowledge that we're brewing right now. Of course, there are many meeting points between digital integration and genetic engineering. For one, some foresee a cyborg revolution on the horizon, redirecting us all with artificial organs, body parts, and cybernetic wearables. In this way, the future might witness a shift towards a more modular human body. Imagine replacing a damaged organ with a synthetic counterpart, or upgrading limbs specifically to enhance strength or agility or dexterity. In all cases, it would make sense to ensure that our artificial add-ins would not only match, but better our organic originals. Again, this could quickly and significantly redefine the limits of human ability. In general, it would enable us to live and thrive in environments previously considered inhospitable. It would allow us to perform any number of tasks previously considered impossible. Here, perhaps the main ethical issue surrounds the question of identity. How much of our humanity can we replace with artificial components before we become something else entirely? Is then the future of humankind also the end of it by default? It's a crossover where our genetic know-how might actually be valuable in preserving ourselves rather than losing ourselves. One of the most important challenges for the future of our species could be to toe the line between embracing artificiality and tempering it, between overriding our genes and protecting them. Meanwhile, we'll likely look to the natural world for inspiration too. For example, were brain implants to one day include sight-enhancing technology, then developers would do well to analyze the mantis shrimp, which has the most complex eye structure currently known, enabling it to see across a far greater visible spectrum. There are also some predictions for bioluminescent humans in the future. In another move that could again dramatically alter our physical appearance, it could be that human skin gets turned bioluminescent simply because we'll soon work out how to do it. If such a change were made, however, then it would serve as a clear and traceable example of evolution fast-tracked by our own actions. More pointedly, we're sure to see something similar take place if we ever do become a spacefaring civilization. In that case, the human body will go through a series of enforced alterations triggered by changes in gravity, atmosphere, etc., but will also likely be artificially enhanced before jetting off into space to better the chances of survival. Think respiratory systems that have been optimized for different atmospheric conditions, or skin that's genetically tweaked to protect against increased radiation. Clearly, there is no one right answer when it comes to picturing our future. There are endless roads we might head down, especially with regard to